think that'll be really helpful for us. So you are watching the video. Great job. Let's go over here though. Let's try a couple examples together now, shall we? So the first example we are going to try to do together to show the prime factorization trees is the number 60. Whoopsie. Right? Now, what are the first numbers you think of when you think of 60? I think of 6 times 10. So I'm going to put 6 here. I'm going to put 10 here. Now, these are the factors of 60, or one of the factors of 60. You could also have broken up 60 into 4 times 15, 5 times 12, 10 times 6, 3 times 20. Any of those would have been just fine for this first step, but I'm going to break it up into 6 times 10. Now, can 6 be broken down into something else? Yes, it can be broken down into its own factors. It can be broken down into 2 times 3. Can 2 be broken down into anything? No, it cannot. 3 can be broken down into anything? No, it cannot. So these two are done. I'm going to circle these. Hope your handwriting's a little neater than mine. What we're going to do now is we're going to try and break down this 10. Can 10 be broken down into anything? Yes, it can. It is not a prime number. The numbers that can be broken down into that are prime numbers are 2 and 5. Since 2 and 5 are both prime numbers, we can go ahead and circle those. And now we've broken down 60 into all of its prime numbers. But is this our answer completely? No. What we have to do now is write the equation. That is our step 4, right? So we're going to go from least to greatest and write every single number with the multiplication symbol in between. I'm going to do text just to help me out a little bit. I think it'll make it a little bit neater for all of us. So our first number is 2. We're going to make this big. 2 times 2 times 3 times 5. And this is going to equal our big number right here, which is 60, right? Now, if I wanted to, I could have also done this. 2, get rid of the 1. 2 times 3 times 5. Now, it's important to go from least to greatest because that's just going to help you stay organized overall, right? And we have to have every single number or else the numbers wouldn't be the same. Because if we did 3 times 5, that would just be 15. And 15 is definitely not the same as 60, right? So this is the prime factorization for the number 60. So let me try another example. Let me try the number 84. First thing I think of when I think of 84 is I think of 4 times, let's see, 4 goes into 8, 2 times, none left over, and 4 goes into 4 once. Perfect. So 4 times 21. It's basically division, and you can always do that over here with this. You can do 84 divided by 2. And you can do a separate division problem over here to help you remember the factors. Especially for bigger numbers like this, that's probably helpful. So, what can 4 be broken down into? Like we did last time, 4 can be broken down into 2 times 2. Are 2's prime numbers? Indeed they are. So we can circle those and show that we're done. Is 21 a prime number though? I don't think so. This 21 can be broken down, if we remember our multiplication facts, can be broken down into 3 and 7. Now both of those are prime numbers, so we can circle those and call them good. So now that all of our numbers have been broken down and they're all prime, we can write our equation, right? So we're going to start with the low numbers and work our way up to the high, and remember to include every single number. So we're going to go with 2 times 2 times 3 times 7 equals a big number, which is 84. Now remember, this equation is telling us that these are all of the prime numbers that make up the number 84, which is our bigger number, right? And we have to include every single number, or else the number wouldn't equal 84. So this is another example. If you want to go ahead and write it down in your math journal for your notes. I am going to have these videos also posted on Google Classroom, because that's how you found them anyway. And go ahead and pause if you need to. Though I'm going to do just one more example, and then I'll explain what our next activity is. So the final number I'm going to do is 99. We're going to do the prime factorization of 99, right? So what are the factors of 99? First one I think of is 11 times 9. Now, is 9 a prime number? No. Is 11 a prime number? Yes, it is. It's one of our bigger prime numbers, which is why I chose this one. Remember, there are prime numbers that are more than just single-digit numbers. They can be double-digit numbers too. So like 11, 13, 17, those are all prime numbers as well. 9, however, can be broken down. 9 can be broken down into 3 times 3. 3s are both prime numbers, so we can circle those as well. Now that all of our numbers are circled, we can begin to write our equation. So we'll start with the lower numbers. Even though 11's on the left, and we can read it like a sentence, we're going to start with the lowest numbers. So we're going to do 3 times 11 equals 99. Remember, all of these numbers tell us the prime numbers that are in the number, the bigger number, 99. Which means that 99 is a composite number, which means that different numbers can be multiplied to equal that bigger number. And remember that this equation is how we show our answer. Without the equation, you probably will only get half credit on homework and assignments. Go ahead and write down this example really quick. Go ahead and pause if you need to. We're going to go back here. So now this is the second video you have watched, right? So great job. Getting through the second video, you've got the teaching, and you've got your notes in your math journal. So what we're going to do is I'm going to stop this video, and we're going to have one more video to go over our next set of instructions. If I can stop sharing, and we'll stop recording, and I'll see you in the next video.